As developers, we obsess over clean code and APIs. But behind every application, every flight you book, and the video you're watching right now, there is something deeper. It isn't just a place to store data, it is the system that organizes reality, the database. Most of us treat it like a digital file cabinet, but the story of the database is actually the story of a trade-off between structure and speed. To build better systems, we have to look at the three distinct eras of how we handle information. Era 1 was physical. In 1890, Herman Hollerith proved machines could read reality using punch cards. But for the next 70 years, data was fragile. It was navigational. To find a record, your code had to know exactly where it lived in the hierarchy. If you changed the data structure, your application broke. It was brittle. That changed in 1970 with Era 2, the relational revolution. IBM's Edgar Cod realized we were doing it wrong. We shouldn't tell the computer how to find data step by step. We should just tell it what we want. This gave birth to SQL. When you write select all from users, you are using a declarative language. This decoupled data from code, introducing the gold standard of reliability, ACID, atomicity, consistency, isolation, and durability. For decades, this was perfect, until Era 3, the scale crisis. When Google and Amazon emerged, they weren't processing rows, they were processing petabytes. Traditional SQL databases running on single massive servers began to crack. Engineers hit a wall of physics called the CAP theorem. It dictates that at a massive global scale, you have to choose. Do you want your data to be perfectly consistent, or do you want your system to be available 100% of the time? You cannot have both. To survive, big tech broke the rules. They invented NoSQL. They traded consistency for scale using the base model, basically available, soft state, eventual consistency. It's why a YouTube view count might lag, but the video never stops playing. This brings us to the modern day. The one-size-fits-all database is dead. Today, architects practice polyglot persistence. You use Postgres for transactions. You use Redis for speed. And for AI, you use vector databases. Vector DBs turn text and images into mathematical coordinates, allowing machines to understand meaning and context, not just syntax. We generate 2.5 quintillion bytes of data every day. The database is now the nervous system of our civilization. The question isn't, where do I save this? It's, how do I structure reality? Go build something solid.